I'd like to do a little more kitchen science with you today. So we're going to be looking at solutions and other types of mixtures. If you remember with me, we have some things that are pure substances. And what did we call those? Elements? That's right, elements. So if we have something like gold, it's just one element altogether. Okay? Then sometimes we can mix things together. Like we said, we could take sodium and chlorine, put them together, and they become sodium chloride. So we're going to look at some of the different types of mixtures we can have where we have different things mixed together. So sometimes a mixture is very obvious. If I take out this cake, we can see that this is not just one pure substance. We can see that there is the cake part and the whipped cream part and the frosting and chocolate sprinkles on top of it that are all different parts. So if I cut up this cake, different pieces might have a little more frosting or a little more whipped cream in that particular piece. It's not one fixed ratio of every part that makes it up, right? So we're going to call these heterogeneous mixtures like this. So something like this, hetero, not the same. So there's different parts that are not the same. Okay? So another example of a heterogeneous mixture might be like this. What if I took pepper and I put my pepper into some water? Alright. So now I've got pepper in water and I stir it up. How long would I have to keep stirring before all of this dissolves and turns into one solution that I can't see the difference between the two parts? I couldn't do that, right? Because the pepper part is not going to become part of the water part. The two parts are separate. This one is a heterogeneous mixture. I can show you, here is the pepper part, here is the water part, and that's easy. Another thing I could do with this is, this one, when we have a mixture like this, we're going to call this one a suspension. A suspension has pieces that are big enough that we can see the actual pieces in it, right? For a suspension, if I wanted to separate this out, I could take something and filter it, right? I could pour this through a filter or a sieve, and then I can see, okay, yes, here's that pepper part right here, and then here's the water part down in my bowl. Okay? So that is a suspension. Okay? I'd like to look at another example here, and we're going to take the corn flour like we used last time that I blew through my tube, and I'm going to put this corn flour in some water. Okay? This one I stir it up, and can you still show me which part is the corn flour part and which part is the water part? Well, they are mixed together pretty well. These particles are much smaller than the pepper particles. And so this one, they mix together and they pretty well stay mixed together. This one we're going to call a colloid. So the thing that makes a colloid is, unlike the pepper, the particles are small enough that they can just stay suspended. Just the normal action fraction of the molecules is enough to keep those pieces suspended in the solution. If I take a light and I shine my light through it, we see that the whole thing looks like it lights up, right? It's scattering the light. So these particles, they aren't small enough that I can see them with my naked eye, but they are bigger than a wavelength of light. So these particles, when the light is going through, it's bouncing off of those particles. And so we can see the light lighting up the whole beaker because it's scattering the light. Okay. If we think of other examples of this, milk. Milk would be another example of a colloid, right? It's got particles in it. It's got fats and proteins in it. And those fats and proteins are bumping around in there. When I take a bottle of milk out, usually the top of the milk is going to just be clear, and the bottom is where all that fat and protein is sitting, right? In a big pile in the bottom. And then I have to take out my bottle of milk and shake it up before I pour it out, right? Let's see. Since I've got a bottle of milk right here, okay, here's my milk. Is that what we see? Is it the top of the milk is all clear and all the stuff inside of it, the proteins and fats, are down at the bottom or up at the top? No, because there's enough motion of those molecules bumping around that they just keep those proteins and fats mixed together in the milk. So that is our colloid. Okay. Now we're going to look at one more example here. And this one, I'm going to put some salt into my water. Okay. And the salt I'm going to stir up, just like I did with my pepper and my cornstarch. But we see something a little different this time. I put in that salt, but now what's happened? Is there one part of this that you can point to and say, oh yeah, that's the water part of it. And another part that you could say, oh, yep, there, that's the salt part of it. Okay. Well, actually, no. That salt gets totally dissolved inside the water. So it becomes one. You can't see any difference between it. Okay. So whereas these we would call heterogeneous, because there's more than one part, something like salt water we're going to call homogeneous. So one type, one part. So this is my homogeneous mixture of salt. Okay, and so this one, if I shine a light through this one, it's not going to scatter the light like my colloid did. That one would scatter it in lots of ways. Okay, so and we can have lots of different types of these solutions. Okay, a couple of examples I might point out. Is it possible for me to dissolve, say, a gas into this water? Sure. Can you think of an example of a gas dissolved in water? Well, soda water would be one, right? So if we have carbon dioxide, we can dissolve carbon dioxide gas into this water. And then that carbon dioxide gas can come back out as bubbles. But when the bottle of soda water is closed, before we open the top, can you see the carbon dioxide? No, it's just right in there. So it's totally dissolved, also a homogeneous mixture. Okay? All right, so I'd like you to look at some of the questions that I've asked you about solutions and mixtures here. And I'd also like you to look at section 1 of chapter 8 in your textbook. So go ahead and read through that section 1 of chapter 8 and then try to answer some of my questions here. All right. Have a good one.